Okay, so we're going to do a problem, and our equilibrium reaction we're going to look at is H2 plus I2 gives me 2HI. Now I can do this in pressures or I can do it in concentrations, because if you have a rigid container, then the moles per liter is your concentration, but it's directly related to your pressure. So you can do this problem with pressure or concentration. I'm going to do this problem with with concentration. So I'm going to be given some initial concentrations. Initial concentrations. I'm going to be given these in the words, okay? It says a closed system initially containing 1.000 times 10 to the negative 3 molar H2. That's initial. 1.000 times 10 to the negative 3. I'm assuming these are all molars. I don't have to write molar in this thing that we're doing. Okay, and then it says 2.00 times 10 to the negative 3 molar I2. 2.00 times 10 to the negative 3 molar I2. And I have no HI to start with. So those are my initial conditions that have been given to me. Sometimes I'll have some HI and it makes a difference to what's happening in this problem. So then they say, after the reaction has reached equilibrium, I get this concentration of HI, and it is 1.87 times 10 to the negative 3. I'm just going to put it here and you'll see why in a second. This is the final or equilibrium. Concentration. So notice I have initial, equilibrium, and in between I have change. What we have is something called an ice table. An ice table, okay? So, if I know that the HI has gone from 0 to 1.87 times 10 to the negative 3, and I know the initial concentrations of my two reactants, I can do something with this. What they want to do is they want to calculate Kc at the temperature that this reaction is occurring in. So I want to find Kc. Right? Now how do I find Kc? Well, if I just knew the equilibrium concentrations of each of these things, then I could have the concentration of Hi squared over the concentration of H2 times the concentration of I2. Everybody with me on this? I want to find Kc. If I only knew what these concentrations were at equilibrium, well, guess what? I could find Kc, couldn't I? So how do we find it? Well, the change in is connected. So if I have a change in the product concentration that I can measure, it tells me the change in of both of these reactants. So what do I change in terms of x? What will my change in be if this is 2x? If the change is 2x, because I've got two HIs, and these are each 1x, okay? What would the change in each of these be? Well, it's 1 to 2, right? So this would be a plus 2x. This is a minus x. This is a minus x. Are you with me on this? Now, what would my equilibrium concentration be? Well, it would be 1.000 times 10 to the negative 3 minus x, wouldn't it? Wouldn't it? And this one would be 2.000 times 10 to the negative 3 minus x. Does everybody see that idea? Does that make sense? If I lose x here, I get 2x of there, correct? And that's how you figure out the 2's and the x's. So I'm losing 1x, I get 2x. I'm losing 1x of this, I get 2x. And that's a relationship, the stoichiometric relationship. So we can figure out the individual concentrations by this 2x. Now what is x? What is x? How do I find x? This is 0 plus 2x. What is x? Could somebody divide that for me?
It's like 9.35
Times 10 to the what? Fourth? Fourth?
No, second.
Well, do it in your calculator and make sure because I don't need to do this in my head.
Because it'd be 0.93. 1.79.
Yeah, it's smaller, isn't it? So I think you're right. Right? He's right, isn't he?
Of course I'm right.
Yes.
Not of course. He just is because he's thinking. Excellent. Hey, we know what X is. Hey, can we put these numbers in there? And you all have super duper calculators, right? Don't you? Couldn't you put in 1.87 times 10 to the negative 3 squared for this one? Couldn't you put in 1.000 times 10 to the negative 3 minus x times 2.000 times 10 to the negative 3 minus x? Could you not do that? Would somebody please do that on their super calculator? Find out what x is. Or, if you don't have a super calculator, you could subtract this from each of those. Try it that way. I'm okay with it that way. I'm going to lose it though. Try it this way. We would have 1.000 times 10 to the negative 3 minus 9.35 times 10 to the negative 4th. Okay? That's what you put in here. Can you do that? So either give me if you have your super calculator, you can set it up like this and just figure out what x is. Or you can put the number in here too. 9.35 times 10 to the negative 4th minus 9.35 times 10 to the negative 4th. Of course, you can always, figure out the number and plop it into that too. Aaron, do you have a calculator? And you should have a calculator at all times. You don't have one in your life? No, serious, you don't have one?
Of those.
What's that?
Not one of those ones.
You don't need one. You just need a calculator. Now, mine got taken. So what's the answer, guys? I'm going to rewrite this. Where's my calculator? I got to stop this. I'm going to stop this and then I'll get my calculator.